আচ্ছা, আমি কি শুরু করব?
হ্যাঁ স্যার।
আচ্ছা, আমার কথা শুনতে পাচ্ছ তো
হ্যাঁ
সবাই?
স্যার।
আচ্ছা। So, in our last class, we were discussing about general graph search algorithms. We discussed general graph search algorithm. That is the same algorithm which we can use for depth first search or for breadth first search. And the input to the algorithm will consist of the start state, the goal state, and the set of rules which can be applied to produce different intermediate states from the start state. And this algorithm will finally provide you a solution path joining the start state to a goal state in the state space. And from that path, you will be able to find the set of rules which, when applied over the start state, will provide you the goal state. So all this we discussed in the last class, and what I mentioned that the time and space complexities for this general graph search algorithm which we discussed in the last class, both the time complexity and space complexity. For this algorithm was big O of b to the power d, big O of b to the power d, where b is the average branching factor of the search tree, and d is the goal depth. So this general graph search algorithms in its present form cannot also be applied on problems of varying sizes, because you should note that both the time complexity and space complexities grow exponentially with increasing solution depth. That means after certain point, if we increase the problem size by a very small amount, the time or storage requirement will be so high that it cannot be supported by a practical system. So that is the problem which I tried to explain by computing the time required to have a solution for tower of Hanoi problem with total number of disks is equal to 64. So again, this algorithm, general graph search algorithm, although it is theoretically provides us a solution for state space search, but it is not of very much of practical use. And here comes the role of AI. AI teaches us how we can use knowledge, and thereby we will be able to make the search in the state space more focused, more directed towards the goal, so that without probing with larger number of nodes to find the goal node, it will simply expand lesser number of nodes and it will reach the goal state much earlier. So in this way, by using knowledge, we cannot change the complexity of this algorithm, but we can have a tricky solution. We can avoid combinatorial explosion, and we can reach the solution much earlier by spending lesser amount of computational resources, namely time and storage. And heuristic search or informed search, it is basically a graph search algorithm. Under this heuristic search or informed search, we will use the same algorithm, that is general graph search algorithm, which we discussed earlier. But by using knowledge, we will make this algorithm more focused, more directed towards the goal node. And this we will discuss under informed heuristic search algorithm. And under heuristic search algorithm, we will discuss two algorithms. One is algorithm A, another is algorithm A star. Both of these algorithms were developed by Professor Niels J. Nielsen. Now, next question is this: how we can utilize knowledge to make this graph search algorithm more focused, more directed towards the goal node. So, in which step of operation of the algorithm we should intervene? Can you tell me? In which step of operation of the algorithm I discussed in the last class?
স্যার যখন ওপেন লিস্ট থেকে কোনো নোটটা বার করব তখন ওই সময়টাতে আমাকে ইয়ে করতে হবে।
So while selecting a node from the open list, we should make this choice of node from the open list knowledge guided. That means when we will select a node from the open list, by some means, by application of some knowledge, we need to know whether that node is much closer to the goal node. And for this, we need a real valued evaluation function. So to make general graph search algorithm, focused So to make general graph search algorithm focus guided towards the goal node, selection of a node n from open list should be knowledge guided. How? So that the selected node is in a close neighborhood of the goal node. So that the selected node is in a close neighborhood of the goal node. The next point is this: how we can judge whether whether one of the nodes from the open list is much closer to the goal node compared to other. For that we need a real valued evaluation function to judge the merit of a node. So we want to have a real volume function which is called evaluation function. If it is to evaluate the merit of a node, how much worth a node in the open list is in relation to its proximity to a goal node.
স্যার এফ এন গ্রেটার দ্যান এফ অফ গোল হবে না?
হ্যাঁ
এফ এন গ্রেটার দ্যান এফ অফ গোল হবে না?
হ্যাঁ 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 সরি হ্যাঁ এফএন গ্রেটার দ্যান হবে। So we want to design a real valued function, real valued evaluation function, which will be able, with which we will be able to evaluate the merit of a node on open list. And this function should be so designed that if this function is applied over the goal node, it will return minimum value. And for all other non-goal nodes, it will return a value which is greater than f goal. And if we can design one such function, in that case, while selecting from a node from the open list, every time we will select a node with minimum f value.
Yes, sir.
Next question is this: how we can design one such evaluation function?
স্যার হিল ক্লাইম্ব মেথডে যেরকম আমরা নাম্বার অফ মানে নোডস নট ইন পজিশন করেছিলাম ওরকম করে তো হবে।
ওরকম করতে হবে। আমি আরেকটা পয়েন্টে আসছি। So what you are telling, that is, you can use a function fn as the number of times out of place in node A compared to goal. So if we write Fn equal to number of tiles out of place or wrongly placed in node A compared to a goal configuration. In that case, when this function will be applied over the goal node, we will find no tiles wrongly placed. So this function will have a zero value. And for all other nodes, it will have a higher value. Can you follow me?
Yes, sir.
And obviously this is for 8 puzzle problem. This is for 8 puzzle. Now, in AI, just finding a solution is not the only objective that I mentioned earlier. The other objective is we always try to find a less costly solution. A problem may have more than one alternative solution, and cost of all these solutions may not be same. While designing an evaluation function, it is true that we want to reduce the search. It is one of our objective. But another objective is to have a less costly solution path. এটা মুছে দিচ্ছি।
হ্যাঁ স্যার।
objectives of designing an evaluation function. Firstly, to select a node from open list which is in the close neighborhood of a goal node. This is to reduce the search. This is to reduce the search or to reduce node expansion. So, and this is to have a less costly solution path. Now, one point you should know that these two objectives are conflicting in nature, because when we select a node which is much closer to a goal node and selecting one such node, we actually prevent the possibility of searching more paths, searching more portion of the state space. But to have a less costly solution, we should search much more paths, isn't it?
স্যার সেটা তো নাও হতে পারে না,
হ্যাঁ,
নাও হতে পারে। আমি যদি ওই মানে লেস কস্টলি সলিউশন
না, কিন্তু if we are allowed to search most of the paths exhaustively, then there is greater possibility that we will be able to find a less costly path.
ইয়েস স্যার, ইয়েস স্যার, হ্যাঁ স্যার, হ্যাঁ স্যার।
And if we are constrained during searching, there is greater possibility that we will miss the less costly path.
Yes, sir.
So these two are conflicting requirements. We have to make a trade-off. So for 8 puzzle problem, how we can make a trade-off? We can design the evaluation function for 8 puzzle. This is only for 8 puzzle. In this way, the depth of node n in such tree, and this is the number of tiles out of place or wrongly placed. So in this way, we can design an evaluation function for 8 puzzle problem.
Yes, sir.
Now the question is this: if there are several nodes on the open list, say N1, N2, and others, when we select a node from this open list, we will select one such node, Fn, select one such node for which the argument of this function, for which the function will have minimum value, or in this way, sorry, in this way, it should be minimum argument. Do you agree with me?
Yes, sir.
That is, the less will be the f value of a node, we will select it. So, in a step of that, I cannot recollect the step number, you will find possibly in the last but one step, there is a statement that reorder
So
the
step 9.
nodes in open list. In step 9, there is a statement reorder the nodes in open list. So if we want to use heuristic search, we will reorder the nodes in open list in increasing order of their f values. That is, in ascending order of their f values. So every time the node with minimum f value will be selected from open list.
Yes, sir.
আচ্ছা, আমি তোমাদের কতগুলো ফিগার ইমেজ করেছি, কি বলে মেল করেছি, দেখেছো?
হ্যাঁ স্যার।
ইমিডিয়েট দেখো, ওটা দরকার হবে। এবার দেখো, let us consider a specific instance of 8 puzzle problem. To explain the role of evaluation function in state space search, let us consider a specific instance of 8 puzzle. Let this be the initial configuration, let this be the goal configuration. So, if this is n, initially if this is n, what will be the value of Fn? That is Dn plus Wn. Dn plus Wn. For this, Dn has a value 0. Because it is the start node. And what will be the value of Wn? Now this 2 is wrongly placed. So add 1 here. 8 is wrongly placed. Add 1 here. 3 is correctly placed in compared to both steps. So add 0 here. Then 1 is wrongly placed. Add 1 here. Then 6 is wrongly placed. Add 1 here. Then 4 is correctly placed. So for 4, add 0 here. Then 7 is correctly placed. Add 0 here. Then 5 is correctly placed. Add 0 here. So what is the value of Wn here? 1 plus 1 2 plus 1 3 plus 1 4. So this is 4. So f of n, when n is a start node, it is 0 plus 4 is 4. Do you agree?
স্যার 5 হবে ওটা, আপনি একটা মিস করে গেছেন।
কোনটা মিস করেছি বলো তো?
স্যার থার্ড রো এর সেকেন্ড কলামটা মিস করেছেন।
ওই ব্ল্যাঙ্কটা?
হ্যাঁ হ্যাঁ,
না, ব্ল্যাঙ্কটা আমি কনসিডার করছি না, আমি শুধু টাইলস আউট অফ প্লেস কনসিডার করছি।
আচ্ছা আচ্ছা, ঠিক আছে।
ঠিক আছে,
হ্যাঁ স্যার।
আচ্ছা এটা মুছে দিচ্ছি, বুঝবো?
হ্যাঁ স্যার।
So initially the start node is in the open list, that is the only node in the open list, so we will select it. This is initially, this will be selected, and f value of this node is 0 plus 4, that is 4. And once it is selected, we will mark it as visited. We will compare it with the goal node, and it fails to match with the goal node. So we will expand this node by moving this blank types 1 position left, 1 position up, and 1 position right. So what we will get? So these are the 3 successors of the start node we will get, and let us come. All these 3 successors will be placed on the open list after this node is being expanded, and next time when we will select one node from the open list, out of these 3 nodes, one having the minimum f value will be selected. So for that, let us compute the f values of these nodes. For this node, it is 1 plus 5, that is 6. Because depth is 1, 6. For this node, the f value is 1 plus 3, that is 4. For this node, f value is 1 plus 5, that is 6. So the f value of this node is 6 in the open list. a value of this node is 4 and a value of this node is 6. So next time which nodes we should select? The node with minimum
Sir,
a value.
the with function value 4.
Huh?
With the value 4.
হ্যাঁ তাহলে এইটা এবার হবে এটা হলো এবার এটা হবে after we select this node from the open list on the basis of the minimum f value what we will do we will first mark it as visited that means we will place it in the closed list then we will compare it with the goal node and here it fails to match with the goal node so what we should do we should expand this by generating all its successors and establishing all these successors in the search graph as successor of this node. So a value of this node is 5. A value of this node is 6. It is in the open list. It is in the open list. A value of this node is 6. It is in the open list. A value of this node is 5. A value of this node is 5. A value of this node is 6. So these are the two nodes with minimum f value. And out of these two nodes, let us select the leftmost children arbitrarily. So third time we will select this node. And after we select this node, what we will do? We will first mark it as visited. Then we will compare it with the goal node and it fails to match with the goal node. So we will generate all its successors. Until we find a goal node, this search will continue. Now I have sent you the complete search tree for this problem. দেখো তো একটু
হ্যাঁ স্যার
দেখছো
হ্যাঁ স্যার
আচ্ছা so that search tree illustrates how heuristic search can be conducted to find a solution for this instance of 8 puzzle, right?
Yes sir.
Achha. Now side by side I have supplied two more figures that which depicts the search trees in case of depth first search and breadth first search applied on the same problem. দেখো
হ্যাঁ স্যার
দেখতে পাচ্ছো
হ্যাঁ স্যার
আচ্ছা now you should know for breadth first search what is the total number of nodes expanded to find this solution path for this problem কত আছে দেখো তো দেওয়া আছে ছবি চলে গেছে তোমাদের কাছে For breadth first search.
5 আছে,
Hmm?
5 আছে।
কটা? 5 5 কি করে থাকবে? টোটাল নাম্বার অফ নোডস এক্সপ্যান্ডেড।
ও টোটাল, আচ্ছা আচ্ছা, সরি স্যার। স্যার 34 খানা।
34 for breadth first search. আচ্ছা, for depth first search
স্যার ডেপথ ফার্স্ট সার্চটা বললাম 34।
আর breadth first search দেখো।
স্যার বিএফএস টা 46 আছে,
হ্যাঁ
46 আছে বিএফএস টা।
আচ্ছা, বলছি দাঁড়াও। একটু দাঁড়াও। প্রথম বলো ডেপথ ফার্স্ট সার্চে কত আছে?
34।
34। ব্রেডথ ফার্স্ট সার্চে কত আছে?
46।
46। আর হিউরিস্টিক সার্চে
স্যার কাউন্ট করছি। স্যার 13।
কত?
13 13।
So this example illustrates how by using a suitable evaluation function we can make heuristic search focused guided towards the goal, thereby we can reduce the number of node expansion during the search process. And these two are blind search methods, and this is an intelligent search method. It is a knowledge guided search. What is the knowledge? The piece of knowledge that we have used here, it tells us that the more will be the number of misplaced tiles in a node, further away will be the node from the goal node, and less will be the number of misplaced tiles in a node, the closer will be the node to the goal node in the state space. That is the piece of knowledge. And how we can encoding it? By using a real valued function, evaluation function, we are encoding it. We could use Fn equal to Gn. Sorry, we could use simply Fn equal to Wn. But in that case, we would undermine the cost of the solution path. And in such cases, it may so happen that the search algorithm may terminate without finding a goal node and without visiting all the nodes in the state space graph. So
Yes,
we need to add this depth component dn plus w. To ensure Done. Bias the search for including larger parts of the state space. That is for DA. The more parts of the state space will be included during search, the greater will be the possibility for finding the least costly solution path. And this is to focus the search towards the goal. Okay, so this example illustrates how an intelligent graph search algorithm, how heuristic graph search algorithm can be applied to make search focused and directed towards the goal. Do you agree with me?
Yes, sir.
আচ্ছা, এটা মুছে দিচ্ছি।
হ্যাঁ স্যার।
আচ্ছা, সবাই বুঝতে পারছো তো?
হ্যাঁ স্যার।
ঠিক আছে, তুমি তো শুধু বলতে, তুমি কে জানো? দেবব্রত, তাই তো? কে কথা বললে লাস্ট?
স্যার আমি।
দেবব্রত।
শুভ্র।
না, শুভ্র কে বললে?
হ্যাঁ স্যার, আমি কথা বলছি।
শুভ্র, আচ্ছা আচ্ছা। শুভদীপ আছো? শুভদীপ?
হ্যাঁ স্যার আছি।
আচ্ছা, বুঝতে পারছো?
হ্যাঁ স্যার পাচ্ছি।
আচ্ছা, ঠিক আছে। At the beginning of our lecture today, I mentioned two types of heuristic search algorithms. What are those? কি লিখেছি?
A আর A স্টার।
So let us first discuss algorithm A. So firstly, it is a general graph search algorithm. It uses the same algorithm we discussed in the last class. And it uses an evaluation function of before. Now, before, in the last example, we consider Fn as Dn plus Wn. that is not a general form of Fn. That is not a general form of Fn that we consider for solving 8 puzzle problem. But there is a general form or generic form of Fn is given as Gn plus Hn. This is called heuristic component or heuristic function. What is heuristic? Or you can write domain specific knowledge. Or firstly, in general form, Fn is expressed as this. Fn is the sum of Gn and Hn. What is this Hn? It is called heuristic function or heuristic component of an evaluation function. What does heuristic represent? Heuristic represents domain specific knowledge or some thumb rule. That means a heuristic is not 100% correct knowledge. It may fail also. It may fail also. If you fail to choose good heuristic function for solving your problem, you may not be able to gain much in reducing the number of node expansion. And Hn should be so designed for a problem that it provides an estimate. It provides an estimate, that is an approximate value of what? Of the actual cost of the least cost path from A to a goal node. From A to a goal node, there may be a path or may not be a path. There may be several paths or may not be one path. And Hn provides an estimate by using some domain specific knowledge. It provides an estimate of what? Estimate of the actual cost of the least cost path joining A to a goal node. Get my point?
Yes, sir.
And what is Gn? Previously we consider it to be the depth of a node. that if we assuming unity arc cost, previously Dn represented the cost of the path joining start node to node n, and here Gn is an estimate of the actual cost of the least cost path from S to N. Why it is an estimate? Can you explain me? Why it is an estimate? Let this be the state space. Let this be the start node, and let this be node n, not the goal node. Goal may be somewhere here. Now, from start node to node n, there may be several paths, and all these paths are initially shown with dotted lines because we do not know how many paths are there, and initially no path has been explored or visited. After this node is visited and it fails to match with the goal node, all its successors are generated. All its successors are generated. Now next time out of this successor, let this one was selected. So it will be first marked as visited, then it will be compared with the goal node. And if it fails to match with the goal node, again it will be expanded. Now, when we discover one path from start node to node A, what is the value of Gn? If the cost of this path is, let the cost be C1. So initially value of Gn will be C1, and after that, if at some point of time this node is reached through another path from the start node, then what we will do? We will, in the graph search algorithm, we will select whether this newly explored path from start node to node A is less costly. If it is less costly, then in the search tree, we will change the parent pointer of this node from here to here. মনে পড়ছে?
হ্যাঁ স্যার।
এবার ধরো এই কস্টটা আছে তাহলে জিএন হবে কি? জিএন হবে Gn is minimum of C1 and C2.
Yes, sir.
After these two paths are discovered, and mind it, there is another path. There is another path in this way. And so long it is not discovered, we will not be able to consider this path, the cost of this path. That's why GN is considered as an estimate of the actual cost of the least cost path from S to N. And if you consider the exact value of GN, it is the minimum of the least costly path so far explored from start node to node N. That is, it is the actual value of GN. Not the actual value. So GN, we can write it as this. So it is equal to minimum of the actual cost of all paths already discovered from S to N.
Yes, sir.
তাহলে GN এর মানে বুঝলে, HN এর মানেটা বুঝলে?
হ্যাঁ স্যার।
আচ্ছা, ঠিক আছে, এবার এগুলো মুছে দিচ্ছি।
হ্যাঁ স্যার।
আচ্ছা, now I am introducing two more functions, G star n and H star n. What is G star n? It is the actual cost of the least costly path from S to N, which we cannot calculate unless the search algorithm discovered all the paths from S to N. And since Initially, all paths may not be discovered, so Gn is considered as an estimate of G star n. Because G star n cannot be perfectly computed unless all the paths from S to N are explored. And what is H star n? It is the actual cost of the least costly path from N to a goal node. And again, unless all the paths from node N to a goal node are explored, this value cannot be computed. So Hn provides us again an estimate of H star n. বুঝতে পারলে কি বললাম?
হ্যাঁ স্যার।
So algorithm A, it is basically a general graph search algorithm applied for state space search with one search with an evaluation function of this form, with an additive evaluation function, that is, which is represented as the sum of Gn plus Hn. And for a specific problem, you need to design this Hn. I have just explained how an Hn can be designed for 8 puzzle problem. এটা মুছে দিই।
হ্যাঁ স্যার।
So again, A star n, again it is a general graph search algorithm. It uses an evaluation function of additive form, that is Fn equal to sum of Gn and Hn. But this Hn for algorithm A star is so designed that it never overestimates the actual cost of the least costly path from N to a goal node. That is, for all nodes N, Hn can be at most equal to the value of the least costly path from N to a goal node. So this is such kind of heuristic function is called an admissible heuristic function. Now, if you want to have an example of an admissible heuristic function, I would mention Wn. That is the number of tiles wrongly placed in node n. That means if you want to reach the goal node from some node n, you have to move, or you have to reallocate at least the tiles which have been misplaced in n. So that is the actual cost of the least costly path if we consider arc cost to be unique, and Wn can never exceed that. So this is why Wn is an example of an admissible heuristic function which we used earlier.
Yes, sir.
So this is algorithm A star. Next, I am going to explain why algorithm A star is important. Why by using an admissible heuristic function we can have some advantage. What is the advantage? এটা মুছে দেবো?
হ্যাঁ স্যার।
আচ্ছা। Now, I have earlier mentioned that the solution for a problem may not be unique always. Depending on the situations, a problem may have more or one solution. Do you agree with me?
Yes, sir.
For example, if you consider traveling salesman problem, in traveling salesman problem, in many ways, we can visit all the nodes beginning from the start node and ending at the start node. We can visit many ways all the nodes only once, beginning from the start node and ending at the start node. So there may be several routes for the traveling salesman problem, but costs of all these routes may not be equal.
Yes, sir.
Now, I have not yet mentioned whether this graph search algorithm will provide us the least costly path. What I have mentioned, that if there is a path joining start node to a goal node, if there exists a path, if there exists at least one path joining start node to a goal node in the state space of the problem, the graph search algorithm is guaranteed to provide us the solution. This much I have just mentioned. But I have not mentioned if the problem has several solutions, which solution will be provided by this graph search algorithm? That I have not mentioned. It is important that algorithm A star is guaranteed to provide the least costly solution if at least one solution exists. That is, there is a theorem, it states that The algorithm A star is guaranteed to provide a least cost path from S to a goal if at least one such path exists. If there exists no path, then algorithm A star will not be able to provide it. But if there exists at least one path joining start node goal node, it is guaranteed to provide you the optimal solution path. Or in other words, it is written as algorithm A star is admissible. ঠিক আছে, বুঝতে পারছো?
হ্যাঁ স্যার।
আচ্ছা, এবার এই থিওরেমটা আমি প্রুফ করব কি করব না এটা একটু করে আমি ভেবে নেক্সট দিনে বলবো।
কেন?
ঠিক আছে,
বলেই দিন
কি বলবো?
এই থিওরেমের প্রুফটা।
এই থিওরেমের প্রুফ প্রথম we have to prove it in parts. In the first part আমি স্টেপগুলো আগে বলে দিচ্ছি। মানে in the form of corollary. ধরো corollary 1, corollary মানে জানো তো? হ্যাঁ, জানো তো?
হ্যাঁ স্যার।
স্মল থিওরেম, তাই তো?
হ্যাঁ।
First corollary is we have to prove that algorithm A star must terminate for the state space graph having a finite branching factor and positive arc cost for all arcs. আচ্ছা, এটা corollary 2, সরি এটা হচ্ছে corollary 2। আর corollary 1 টা কি? corollary 1 হচ্ছে is this? Corollary 1 is anytime before a star terminates, there must be a node n dot on open list which is on an optimal path from S to a goal node with the f value of this f dash is less than equal to f star s. I have not yet explained what we mean by f star s. I shall explain it. This is corollary 1, this is corollary 2. Then corollary 3. আর corollary 4 হচ্ছে corollary 4 তাহলে corollary 1 হলো anytime before a star terminates there must be a node n dot on open list which is on an optimal path from S to a goal node with fn dot less than equal to f star s. I shall explain what we mean by f star s. This is corollary 1. This is corollary 2. Algorithm A star must terminate for the state space graph having a finite branching factor and positive arc cost for all arcs. Corollary 3. A star must terminate by finding a goal node. Corollary 4. A star must terminate by finding a goal node on an optimal path from start node. আচ্ছা এটা হচ্ছে corollary 4 এটা হচ্ছে corollary 3 আমি শুধু আজকে এই f star s টা বলে দিই f star s টা কি f star s is আচ্ছা f star s টা বলার আগে আমি বলি f star n টা f star n হচ্ছে g star n plus h star n
স্যার এফ স্টার এন কোনটা?
h star n বলেছি তো আগে
এফ স্টার
f star n টা হচ্ছে g star n plus h star n
আচ্ছা ঠিক আছে। না কিন্তু করোলারি 1 এ তো ওটা এফ এন ড্যাশ লেখা আছে।
হ্যাঁ it is less than equal to f star s
হ্যাঁ এফ এন ড্যাশটা কি?
n dash একটা নোড
আচ্ছা
n যেমন আছে n dash একটা নোড
ঠিক আছে
এটাকে কেন n dash বলেছি it is on an optimal path from start node to a goal node
ঠিক আছে
এইটা কি হলো, f star nটা কি হলো? It is the cost of that optimal path from start node to goal node which passes through node n.
Yes, sir.
So it is the cost of an optimal path from start node to a goal node and passing through node n.
হ্যাঁ স্যার, বুঝতে পেরেছি।
There may be more than one optimal path, and all optimal paths from start node to goal node may not pass through node n.
Yes, sir.
And f star n is the actual cost of the optimal path from start node to goal node passing through node n.
বুঝতে পেরেছি।
আচ্ছা, আর f star s টা কি? f star s হচ্ছে বেসিক্যালি
Optimal path starting from start node to
goal. It is the actual cost of the optimal path from start node to goal node. There may be several paths. Out of those, one is optimal,
হ্যাঁ স্যার।
and this star s, f star s is the actual cost of the optimal path joining start node to a goal node.
হ্যাঁ স্যার।
ঠিক আছে?
হ্যাঁ স্যার, বুঝে গেছি।
আচ্ছা, এবার এই চারটে করোনারি প্রুফ করলে ওই প্রুফটা হবে যে অ্যালগরিদম A star is guaranteed to provide an optimal path from start node to a goal node if at least one path from start node to a goal node exists. ঠিক আছে?
হ্যাঁ স্যার।
আচ্ছা, আজকে এই অবধি থাক। আমি তোমাদের একটা অনুরোধ করছি, আমি এই এত থিওরেম আমি বলে দেবো, হ্যাঁ, তবে তোমরা একটু বইটা দেখো যারা ইন্টারেস্টেড, ওই নিলসনের প্রিন্সিপালস অফ আর্টিফিশিয়াল ইন্টেলিজেন্স,
ঠিক আছে
এই
স্যার।
বইটা দেখো।
হ্যাঁ স্যার।
নেক্সট ডে, আচ্ছা তাহলে নেক্সট স্যাটারডে ক্লাস হবে, কালকে আর হবে না। স্যাটারডে 4:30 হবে না, একটু দেরি করে হবে। দেখি কে একটা কি বলছে, কি স্যার বলছে এরকম করতে পারে। তাহলে স্যাটারডে কখন হবে? 4:30 তো? কেউ একটা বলছিল যে একটু দেরিতে নিন, কি গো? স্যাটারডে দেরি করতে ভালো লাগে না, কি হবে বলো কিছু?
স্যার, একজন আফটার 6 লিখছে।
হ্যাঁ,
একজন আফটার 6 লিখেছে।
আফটার 6? স্যাটারডেটা আফটার 6টা বড় বেশি। কেন, তোমার কি প্রবলেম আছে দেবব্রত? শনিবারটা ফাঁকা হয়ে যায় না ডিপার্টমেন্ট? আচ্ছা, 5টায় হোক, মাঝামাঝি হোক, ঠিক আছে 5টায়। তাহলে নেক্সট ক্লাস উইল বি অন স্যাটারডে at 5 PM, তাই তো?
হ্যাঁ স্যার।
ঠিক আছে, আর তার আগে তোমরা নিলসনের প্রিন্সিপালস অফ আর্টিফিশিয়াল ইন্টেলিজেন্স থেকে পড়বে। তোমরা ডেপথ ফার্স্ট সার্চ, ব্রেডথ ফার্স্ট সার্চ, গ্রাফ সার্চ অ্যালগরিদম এগুলো ইমপ্লিমেন্ট করার চেষ্টা করো, সিতে হোক পাইথনে হোক যাতে হোক কোড লিখে, তারপরে একটু আমাকে দেখাবে, আমিও একটু বলবো তোমাদের কিছু কিছু, ঠিক আছে?
হ্যাঁ স্যার।
আচ্ছা, তোমার তো আমি অনেকদিন বলছি শুক্র
হ্যাঁ স্যার।
আমার সাথে,
ঠিক আছে স্যার।
তুমি প্রোডাকশন না?
হ্যাঁ স্যার।
আচ্ছা, তাহলে একটু মিট করো,
ঠিক আছে।
এখানে একটু কথাবার্তা বলবো।
ঠিক আছে স্যার।
আচ্ছা, আচ্ছা আমি লিভ করছি।